In this problem, we have a 20-kilogram rectangular raft, which is 2 meters long, 0.75 meters wide, and 0.2 meters thick. We want to first find out how much water does the raft displace. Second, we want to find out what is the buoyant force acting on the raft when it is completely submerged in the water. And lastly, what mass can this raft support before it starts to sink? Now, in this first part, of course, as always, we draw our picture of what's going on. We have a raft, and we're given the dimensions of the raft as 2 meters long. It is 0.75 meters wide. And it is 0.2 meters thick. And what we want to do is figure out how much water does the raft displace. And in terms of how much water, we're looking really for the mass of the water that's being displaced. We know the mass of the raft is 20 kilograms. And then we know the dimensions of the raft, the length, which is 2 meters. We have the width, which is 0.75 meters. And we have the height, or the thickness, which is 0.2 meters. Okay, so we want to get the mass of the raft in letter A, the mass of the water being displaced. And we are told that the density of the water is 1,000 kilograms per cubic meter. So the connection here between mass and density is our formula that density is mass divided by volume. So if we want to find the mass of the water, we're going to have to use the density of the water. And we simply need the volume of this much water. The volume of the raft itself is the same as the volume of the water it's displacing. So to get the volume of a rectangle, it is length times width times height. So we have 2 times 0.75 times 0.2. This gives us a volume of 0.3 cubic meters. Now we can come back here and solve for the mass of the water being displaced. Our density of the raft is 1,000. We're solving for the mass of the water displaced, and the volume is 0.3. We multiply the 0.3 to the other side, and we get the mass of the water being displaced as 300 kilograms. Now that's part A. And part B, we're asked to find out what is the buoyant force acting on the raft when it is completely submerged in the water. So for part B, we're finding the buoyant force. Our formula for the buoyant force is that it is the mass of the fluid displaced times gravitational field constant, which is 9.81 newtons per kilogram. So it is a lot like the gravitational force, only in this case the mass is the fluid that is being displaced. Again, it is, if we go back to our diagram, it is the volume, or I'm sorry, it is the mass of this much water. It is the same as the volume of that much water, I'm sorry, the mass of that much water times 9.81. So if we were to take this much water and put it on a scale and find its gravitational force, that is the same as the buoyant force. Now we just solve for the mass of that much water in part A. And the mass of that much water is 300 kilograms. This then gives us a buoyant force of 2,943 newtons. In part C, we want to know how much mass can we place on top of the raft before it starts to completely sink to the bottom. And so our free body diagram, it is floating, and so the upward buoyant force is going to balance out the gravitational force. But this is the gravitational force not just of the raft, but remember we're going to put an object on top of this raft. And it is going to be the gravitational force of the mass on the raft as well as the raft itself. So first of all, we are in equilibrium because the object is neither rising nor sinking. And so therefore the two forces are equal since we're in equilibrium. We know the buoyant force from part B, and therefore we know the gravitational force. But remember that this is the gravitational force not just of the raft, but the object on top of the raft, which I'll label as M sub O, O for object. So gravitational force is M, but it's the total M times G. And that is equal to the buoyant force, which we got in part B. So at this point, we can place in our numbers. We have 2,943. The mass of the raft, which we go back here, we saw that the mass of the raft was 20 kilograms. We're going to get the mass of the object on top of the raft. That's our one unknown. And then G, of course, is 921. As we saw, we get that the mass of the object is 280 kilograms. We divide by the 9.81, and then we subtract 20. So again, if the object is neither rising nor sinking, if it's just floating there, then the buoyant force is equal to the gravitational force. In this case, we had to get the buoyant force first. It's the mass of the fluid that is being displaced. In this case, we got to think about what fluid is surrounding the object. That's the fluid being displaced. The fluid around the object, which is the water. So we find that mass of the same volume of water as is submerged in here. And then we multiply by 9.81. And then we eventually solve for the mass of the object that is on top.